Hello everyone. In this video we're going to be going over fractions as we have been in the past few videos, but this time we're going to be talking about order of operations and how it affects calculating or solving fraction problems. Okay, I know overseas they mostly use BODMAS, but here in the US we use PEMDAS. So I'll just write both down and use your own, you know, use whatever you like. There's no right or wrong here. So I'm just going to represent them symbolically. Don't have to write them out. It's actually more useful that way, or this way. So this here stands for bracket. This is order. And this is division, multiplication, addition, subtraction. This is parentheses, another way of saying bracket. And this is exponents, multiplication, division, addition, and subtraction. I know some will be questioning why you have division first here, but multiplication first here. The truth is either one can go first, and likewise this, if you have the subtraction here, the addition here, it wouldn't make any difference. But when you have division and multiplication next to each other, what you want to do is you want to start from the left hand side. So we go from left to right, just as you read from left to right. So you will solve the math problem from left to right. With that, let's do some examples. And here I'll be showing you the commonly made mistakes and also some assumptions that people, well, I guess assumption is part of the commonly made mistakes. So let's get into it. Okay, let's look at this problem here. This is 2 divided by 3 plus 3, 5 minus 2 to the 9, not to the 9, divided by 9, 7 divided by 3. Okay. Okay, let's go ahead and solve this here. So using BODMAS, well, actually, looks like I'm missing one while we add subtraction somewhere, just to have them all in. So using the order of operations, we know we can't just solve these two first because it's going to be wrong. And here we have these two together. We don't know if we should do this first or do this first. And in this case, we've already said, we've established that we would solve it from left to right. And so just for, this example's sake, I am going to go ahead and just put a bracket in the section we're going to be working on. So that remains the same, plus sign. And here we're just going to be multiplying across. Actually, what I will divide this to reduce the numbers we're going to be dealing with. 3 here is 1, 3 here is 3. So 1 times 2 is 2. 5 times 3 is 15. Divided by 7 3 minus 2. Okay. Now obviously the next operation is going to be division. Let me put this here again. I wouldn't do it for the next example. This is just to help visualize what we're doing a little bit better. So this remains the same. Plus, and here we know that we're going to change this to the multiplication sign and flip this fraction. So that becomes 3/7 minus 2. Let's go ahead and divide here. 3 here, 1. 3 here is 5. And we're going to have 2/3. So 2 times 1 is 2. Divided by 5 times 7, that would be 35. Minus the half. So here we have operations that are of the same power, so to speak. They carry the same weight, and so we're gonna go from left to right, as we've mentioned previously. So we're going to be doing this first. Okay, so here we have so the lowest common denominator, or lowest common multiple, at the bottom there would be well, to keep from having to think about it for a long period of time, I'm just going to multiply it out. That'll save me some time. So we have 3 times 35. I think I might need a calculator for this one. Actually, not necessarily. 3 times 5 is 15. 5, carry 1. 3 times 3 is 9, plus 1. That's 105 is 10. So 3 and 105 will be 35, times the 2 in the numerator, plus 35 and 105 will be 3, times the other 2 in the numerator. So that's 70 plus 6 divided by 105. And that's a half. Plus 76 divided by 105. Doesn't look like I can divide that because 2 doesn't go here. Plus 3, no, 3 doesn't go here either, so I can't divide that. Further, so we have this left, and likewise we find the lowest common multiple, and in this case we multiply as well. So 2 times 5 is 10. 2 times 0, 0, the 1 we carried. 2 times 1 is 2. So 105 and 110 is 2 times 76 minus 2 and 210 is 105 times the 1, and I'm writing an equal to signs. Anyway, matters not. So here we have, that's 12, 14 plus 1, 15. Minus 105. I should probably done this too. Make sure it turns out nice and tidy, but doesn't matter. Okay, so 152 minus 105. Must be 7 there. 47 divided by 210. That's it. Maybe next time I'll work it out. So well, it doesn't have to, because not every not every question presents itself nicely or kind of reduce itself and come out, in a simple manner. Some can be messy. So anyway, that's the answer to that one, and then we're gonna go ahead and go to our to the second example. Okay, for the second example, I'm just going to have 2 plus 2. So some people see this and perhaps may want to rewrite it, maybe in that form that they like better. Maybe they like it, in a linear form, like, this. But if you write this as this, you're making a mistake because they're not the same. So whenever you see this division line, it's assumed that you have a parenthesis or bracket in the numerator. As such, if you want to make this equal to this, then you have to have parentheses here and here, a bracket here and here. So essentially, if you're writing code in C++, or you're trying to solve this in C++, ensure that you have brackets here and here, even though you don't see it here. It's just an assumption. It's something that you should know. If you don't know that, then you're not going to get the right answer. So why don't we solve this, which is the correct, well, we're going to solve this here and solve this and see what answers we get. So we're going to make this one A and make this B, just to check to see if it's equivalent. Well, obviously I know it's not, but just so you know the different answers you're going to get and how it's going to be wrong. So since there's a parenthesis, an assumed parenthesis here, we're going to go ahead and add this first. So this is 207. Oops, I didn't have to rewrite that. Which is equal to 7 minus 7 is 7 times the 2 plus 7 and 7 is 1 times the 2. I like to exaggerate the major division line. That way you don't start confusing it with other division lines. It's very easy to do. We're going to do another example where I'll show you how easily one could confuse this with this or this, depending on how you write it down. So that's 14 plus 2 over 7. Put out, make sure it's long. It's so long. Minus 2. So that's 16 divided by 7. And that's 2 times 3, 6. Divided by 4. We'll go ahead and reduce this here. 2 here, 3. 2 here, 2. And so now we have this. What we're going to do is that we're going to change this division line to multiplication, and then flip the fraction after this division line. Okay, so let's now become 16 divided by 7 times 2 over 3. And this gives us 32 divided by 21. I don't think that divides. 3 doesn't divide here. 3 goes here. The 7 go here. Let's see. No, it doesn't. So, well, this here is an improper fraction. We can rewrite it as a mixed number if we choose. So let's go ahead and do that. And 21 goes in 33 just once. And there is 11 left, divided by 21. So that's the final answer. So now let's solve the part B. See what we get. We're going to be doing this first. It's going to be 2 plus 2 over 7 times 1 over 2. Cancel 3 times 3 over 4. You have 2 plus 1 times 1, and then 7 times 1 times 3 divided by 4. And now we're going to be dealing with this. So that's 2 plus 3 divided by 7 times 4 is 28. And here we look for the lowest common multiple, and that will be 28 in this case. 1 and 28 is 28 times the 2 plus 28 and 28 is 1 times the 3. And this gives us 56 plus 3 divided by 28. It's going to be 59 divided by 28. I think 59 is a prime number, and as such we won't be able to divide any further, but as the previous one, this is a mixed number, an improper fraction, and we can rewrite it as a mixed number. So 28 and 59. Wait a minute. Let's divide. Let's see. It's in 2 times 28, 59. Oh, sorry. 8 plus 8 is 16. Sorry, I don't know what I was thinking. Anyway, so 2 times 28 is 6, 56. So okay, so it goes twice. There's 3 left, and then the 28 that we divided by. Hope I didn't make any mistakes. But as you can see, obviously the answers are not the same, and that tells you that this and this are not the same. And that's going to be the end of this video. In the next video, we're going to introduce law of indices and apply to fractions. And I think after that, we're pretty much going to be wrapped up with fractions. You should have known everything there is to know about fractions. Well, thank you for watching. Subscribe, like, comment, share, and have a wonderful day.